So we're going to look at number 6. Make sure you're writing this on number 6. Everybody shifted down. We're looking at the bottom. Okay. All right. So hold on. Let me make sure. Okay. All right. So based on this one, we have a vertex of what? Okay, we have a vertex of -8, -3. Okay. So left 8, 1, 2, down 3. Okay. And then if you guys remember from the video, there's kind of a shortcut for this, right? Do you guys remember how the shortcut works? We have like a negative version, we have a positive version. So I'm going to say, okay, so let's okay, so let's walk through this, okay? Well, do you want me to draw the picture and then we can walk through the steps and just kind of make sense of it? Okay, so this has a vertical compression, right? So it's upside down. It's going to kind of go this way. I'm going to sketch this, though, because it's a compression and I'm not drawing a compression yet. So this would be normal, but that's not a compression, right? We agree with that? That's not a compression? Okay. Now, a vertical compression would be like half as tall as that, right? It wouldn't go over 1, down 1, over 1, down 1, over 1, down 1. That would not have the 1/2. This would just be the upside down part. Are we all in agreement? Okay. So what the vertical compression would do is it would go over 2, down 1, over 2, down 1, over 2, down 1. Do you guys see how it's wide? Over 2, down 1. That's what it would do. Okay, so this is what our V would actually look like. So when we split our piecewise function in half, we're splitting it in half at the -8. We're splitting it always because we split from left to right, so we always split it at the x value. We look at everything to the left of the vertex, we look at everything to the right of the vertex. Does that make sense? Okay. Now, on the left side of the vertex, we have the opposite of the sign. So it's a negative sign. The opposite of a negative is a positive slope. We agree with that? Okay. On the right side of the vertex, we have the exact same sign. So negative, negative slope. Okay, so now I'm just going to show that work. I'm going to say the opposite of a negative slope, and then we had x plus 8. I'm doing parentheses instead of an absolute value sign because whenever I take my absolute value and write out my 2 different options, that's when I take away the absolute value sign. And this is if x is less than -8. So this is me saying I'm talking about the left side. So this is the negative version, my negative version. And then my regular version, I'm not adding a negative in the front. I'm just keeping it the exact same. No negative in the front. So this is if x is to the right of -8. So the right side keeps the sign the same. The left side adds an extra negative to the front. Now, one of these needs an equal sign. Doesn't matter which one it is. No, which one do you guys want to do? The bottom one. Okay. Doesn't matter. Okay. So what we're going to do next is we're just going to simplify this. We're going to compare it to the graph. We're going to make sure it makes sense. That's all we got to do. Okay. So minus minus makes a positive. Okay. So I have positive 1/2 multiplied by x. Oh, marvelous. Okay. 1/2 x. And then positive 1/2 multiplied by 8. Okay. Okay, so the first part of our piecewise function is 1/2 x. The second part is plus, not 4, 1, plus 1. Good. Okay, if we look at the left side. Okay, so let's kind of extend this pattern and just make sure that makes sense. So that's not really the graph, but does that make sense? Yeah, that makes sense. So this is not actually drawn, so we're not going to keep that, but that makes sense. Okay. Okay, good. All right, and then for the other one, we're going to do negative 1/2 multiplied by x to get a negative 1/2 x. Negative 1/2 multiplied by 8 to get a negative 4. So we've got negative 1/2 x, and then what do we have? Minus 7. If we're looking to the right of the vertex, and does this fit the right side? Does it fit? Y-intercept of negative 7, slope of negative 1/2. Yeah, it fits. Okay, so this is our final answer. Okay, did that clear up some of the confusion we had when we first saw it? A little bit? Okay. A little bit? So we got one more. Okay. We got this one. Now I'm gonna jog your memory. This is not part of the notes. We're gonna do this off to the side. Because finding the vertex, it should take you back to factoring just a little bit. Does it take you back to factoring? Like, oh, if you had factored x plus 1 and x minus 3, and I said, ooh, tell me the solutions, you would tell me, oh, the solutions are... Yeah. Negative 1 and positive 3, because they're the opposites, right? So when you find the vertex, you're finding the opposite of the inside. Okay, but it's kind of like factoring. It's the opposites, okay? And if I told you to find like x plus 5, x minus 9, you'd be like, oh, okay, those solutions are negative 5, positive 9. And then we go, okay, but there were some special factors like 2x plus 1. And then that factor, it wasn't a whole number. Do you guys remember how that one worked? It was still the opposite sign. We might have to go back to where these factors came from.
Yeah, you put it as equals 0.
Yeah. So if you think back to these factors, the way that you did it, so the shortcut was just do the opposite sign. But when you very first learned it, the very first time you said x plus 1 equals 0, and you subtracted 1, and that's how you learned it was the opposite sign, was you had to subtract it over for something. So same thing here is if you had one of these and you didn't know how to solve it, you would just set it equal to 0, 2x plus 1 equals 0, and you would subtract the 1 over, you'd get 2x equals negative 1, there's your opposite sign. And then you would divide by 2. And so with factoring, you'd be like, oh yeah, if there's a number in front of the x, those were the ones that had the fraction answers. Do you guys vaguely remember that? Yeah. Okay, so if we had one that was like, let's just practice a few of these and make sure that we still remember. So if we had one that was like 3x minus 5 4x plus 11. If we had one like this, what would the answers be?
I think it would be fraction.
Yeah, so positive 5 over 3, negative 11 over 4. Okay, so let's go back to example number 5. Okay, so example number 5, it does not have a number in the front, so I'm going to say this is f of x equals, if you want a number for a, you could just stick a 1 there, if that's kind of nice to, oops. I want you to see it. So there's no number there, there's no negative, there's no reflection over x, there's no stretch, there's no compression, because there's no number in the front, it's just normal. So if you want a number there, you can put a 1 just to remind yourself that, like, if it had a number there, it would be a 1, but that just tells us that it's like a normal, that's a normal graph. It has no number on the end, which means that the number on the end is actually a 0. Okay? All right, so if we were to look at the vertex for this one, what would the vertex be? It wouldn't be 2. It'd be positive 2 sevenths. It'd be 2 sevenths, comma 0. So this one's actually a fraction.
Why is that different?
Because it's like this from factoring. Isn't that interesting? It's like,
Solving it like a different way?
no, you're doing it just like, so all of these have really been just like factoring. They're always just the opposite sign. The rest of the problem is going to work out the same as everything. It's just that the vertex on this one is weird. I wanted to show you one with a weird vertex. But the rest of it is going to be the same. Yeah. So now this doesn't have any upshift. It doesn't have any stretch or compression. So what we're going to do is we're going to graph that vertex. 2 sevenths goes over 2 sevenths, 0. And then from there, the normal V-shaped graph on each side, they just go over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. So I'm just going to go over 1, up 1, over 1, up 1, over 1, up 1. I don't love graphing this, but it's not the worst thing I've ever seen in the world. It just makes me a little bit uncomfortable. So they're just all fractions, really. Because that's a normal V-shaped graph. That's the perfect V. Yeah. Yeah.
Why is this one different than the rest?
It's actually the same. It's just because the vertex. This is the only one we've ever done that had a number in front of the x. That's when you get the fraction. Yeah. Yeah, so technically, we could have looked at this the whole time. We could say this was negative 8 over 1. We could have treated them all like fractions, because technically it works the same. Because technically the x always has a coefficient, but none of us ever do that. We always are like, well, in this case, you just do the opposite number. But we've been solving these like factoring the whole time. We've been saying, do the opposite, do the opposite, do the opposite. We just didn't realize that's what we were doing because we never had to do one like this. So we didn't really completely make the comparison until we got to this one. Yeah. Okay, so we've got this. Now, we're still going to do, I'm just drawing this line down because we're still going to do the thing before where we do like, we think about the left side, we're going to think about the right side, we're going to think about doing the opposite signs, we're going to think about doing all that stuff, okay? So I'm going to start writing my piecewise function. I know that the vertex splits it in half right in the middle, and we do the left side of the vertex as one half, the right side of the vertex is the other half, and we know that we always split it at the x value of the vertex, right? Because we're always thinking left and right, so it's always the x value. I know that the left side is just you stick a negative in front of it. So I'm going to stick a negative in front of the left side. This was positive to start out with. So when you stick a negative in front of it, it's a negative slope. That matches my picture. It makes sense. Okay? So I'm going to take my equation. I'm going to stick a negative in front of it. And then 7x minus 2. I don't need my absolute value sign anymore. And that's because I think this works out. I don't need my absolute value sign. I think I made a mistake that I made the last time I did this, actually. Hold on, I vaguely remember this from last year. Let me double check something. I just had a mini panic attack, you guys. You know what? Go ahead and okay, hey guys, here's what we're gonna do. Are you guys ready? Okay, we're gonna scribble this out right here. We're gonna keep doing this, but without the picture, because I just realized that I made a math teacher mistake, and I don't want to confuse you guys with the picture. Okay. So instead, I'm going to use this little bit right here. So I'm still going to be able to use my picture to help me think through common sense, but I'm not going to get bogged down with the points. Does that make sense? Okay. Now, it's kind of weird. Here's the mistake that I made. There's a 7 in front of the x, which is a transformation. It's just one that you learn in pre-calculus, which means that this graph does not go over 1, up 1, over 1, up 1. But I'm not going to get into that because you learn about it in pre-calculus. Okay? So this graph is this shape. I didn't lie to you about that. It does have a vertex at 2/7, 0. I didn't lie to you about that. What I was wrong on is it doesn't go over 1, up 1, over 1, up 1. That was wrong because of this 7. But this is something you learn about in pre-calc or math 4, and I don't want to teach you guys something a year ahead of time. We can do this with the shortcut, with having a general picture and not specific points. Does that make sense? Okay. All right, so we do know that the picture is split in half at the vertex. We do know that the left side of the picture has a negative slope. We agree with that? Okay, so we're going to say the left side of the graph, we stick a negative in the front. We're going to say if x is left of the vertex, okay? And then we're going to say use the positive version of the graph if x is right of the vertex. So see how we're still using those shortcuts? So we're saying negative on the left side, positive on the right side. Now, one of these has to have an equal to sign. Which one do you guys want it to be? Top. Marvelous. Okay. So now, what do we need to do? Simplify. So I'm going to take my negative, and I'm going to distribute it. And what do I get? Okay, negative 7x plus 2. If x is less than or equal to 2/7, okay? Now, this left piece, does that fit? It has a negative slope and a positive y-intercept. Does that fit our picture? Yeah? Okay. For the other one, it's just positive. We don't really need to distribute it though. Do you guys see how we are basically simplified already? There's no number to distribute, so we're just done. 7x minus 2. So if we look at the right side, I'm going to kind of extend this so I can see the rest of the picture. Does that fit positive slope, negative y-intercept? Does that fit? Okay, so that's reasonable. All right, there's our piecewise function. Okay. Does that help us make sense of the notes last night, or would we like to see one more? It makes sense? Okay. I can give you guys one more if we need to. No? We got it? Okay. There are two things on the agenda for today. One is